Okay, so continuing on, I've decided that we'll go through a few more practice questions on differentiation. Let's proceed. So we want to find the derivative of this function. So we can transform the radical sign, rewrite it as this, and then we apply power rule. And then the derivative of whatever's inside the parenthesis. And then we bring this down so that the negative sign would be turned to positive. And then, well, just rewrite the raised to 1/2 as a radical sign again. And this is the answer. Next, another one. Okay, so instead of using quotient rule, it saves more time if we just reciprocate, like so, and then apply power rule. -7 minus 1 is -8. Derivative of whatever is inside, so that's going to be 2x. Bring this down. Okay, I think this is the answer already. How about a little more? It's not easy for me to speak right now, unfortunately. I have a mouth sore, so please bear with me. So this is the answer for that. Very easy. Next. Power rule. So this is the answer already. Next. Okay, so this is a little spicier this time. We just rewrite this as x raised to 1/3. Whatever is in the denominator of our exponent is the one here. So let's say this is like that, or in other words, just this. It's written as raised to 1/2. So since that there is 3 here, so there is also 3 in the denominator. I hope you get the logic, the analogy behind it. Okay, 4x raised to -3/2, because here it's just a 2. If it's invisible, then that's automatically 2. It's an implication. Okay, and then let's start applying power rule. 2 times 1/3, that's 2/3. 1/3 minus 1, or in other words, 1/3 minus 3/3, that's -2/3. Since both of these are negative, it's going to be a positive. 4 times 3/2, 6. -3/2 minus 1, that's -5/2. Positive 3 times -6, that's -18. And then -6 minus 1, -7. We could leave our answer like this, but if we want to remove the negative exponents, the negative sign basically, and the exponents, what we'd want to do is this. So reciprocate basically. 6 over x 5 2, and then minus 18 over x raised to 7. We can further simplify this term. In that case, it would be x squared times x. When we liberate it, these two, it's gonna be x squared times x. So it's the final and the most simplified answer would be this. Okay. Next, y is equal to 1 over x. Okay. Reciprocate, and then power rule, negative x raised to negative 2, or negative 1 over x squared. That's the answer. What about this? Again, since we have a fraction, we have to think or consider if we have to apply quotient rule. But recalling what has been stated in the previous video, quotient rule is most applicable if both the numerator and the denominator have variables. In this case, there are none. Same thing, actually, in the previous example. Our numerator is just a constant. So is our the case in our example right now. So we can just, let me think. We cannot apply power rule as simply as the previous question, but even though, like I said, quotient rule is most applicable if there are variables in both the numerator and the denominator. But it doesn't mean that it's only restricted to that condition. In this case, we can still apply quotient rule. So again, just copy the denominator and then find the derivative of the numerator. Numerator is a constant, so automatically 0. And then just copy the numerator and then find the derivative of the denominator. So 3x squared minus 8x plus 1 over and then put a square. That's it. Negative 6x squared plus 16x minus 1. Minus 2. And then below, we just copy. At this point, this could be the final answer already. Next. Okay. There are two ways to solve this. We could use product rule, or we could just simplify, apply FOIL method first. Like so, and then we start deriving. So for each term, 6x raised to 5 plus 4x raised to 3 minus 2x. Yeah, this is the final answer already. So clearly, not using product rule is a wise choice. It saves a lot of time. But let's try to do it anyways to show you a comparison. So derivative, let's say we're gonna assume that this is f of x. This one is g of x. Okay, so derivative of f of x, and then just copy g of x, and then a plus, copy f of x multiplied by the derivative of g of x, which is 2x. 4x raised to 5 plus 4x cubed plus 2x raised to 5 minus 2x. Okay, so 4 plus 2 is 6. 4x cubed minus 2x. Same thing actually. In more complicated questions, you have to identify which is the method that will grant you the least time to solve it. Um, so right now, it's not that it's kind of subtle in a way. It's not significantly longer compared to when solving uh, by simplifying first using FOIL method. But like I said, I've seen worse questions, and you'd really want to find the least to find the method that saves the most time, because time is a luxury you don't have. I mean, it's very scarce, especially in exams, or at least from my experience, it's not necessarily a luxury. Rather, when you get stuck in a problem that's worth a lot of points, so you spend a lot of time with it, and if you're not able to get it in due time, then you're screwed. Moving on. Okay, so maybe we could factor something. No, I don't think so. This is 5, this is 3. It doesn't look like. Let's just use quotient rule. Okay, 15 x squared negative 4 negative 10 plus 16. Okay, next. Okay, radical sign protocol is we transform it to exponential form like this, and then power rule. And then derivative of what's inside. Yeah, that's 9. Okay. Okay. That's basically it. Okay, this is the final boss. What if you have to answer something like this? Muhahaha. Anyways, let's solve it. So before deriving, let's see first what can. No, actually, let's start deriving already. No. And then power rule. You can just rewrite this back to radical form. And then derivative of what's inside. So this becomes 0 because it's a constant. Here we apply power rule. So bring down 1/2, copy this, and then we have a negative 1/2 in the exponent form position. and then -1. That's it. And then simplify. Okay, and then just merge them. Okay, that's it. Done. Okay, we're done with derivatives. Are we? Okay, I think I'm supposed to teach this first, but we're already here anyways. There's another way to find the derivative of a function. That is through the 4-step rule. Let me introduce it to you now. So, how does it work? So let me just write this down first. So derivative of f of x is equal to the limit as delta x approaches 0 of this minus f of x divided by delta x. So how's that relevant? These are the instructions.